without further ado, Rachel, KK60AC, take it away.
Thank you, Rob. And thank you for inviting me. I really appreciate that. I know most of you out there. First thing I want to ask is how many people have a mesh node at their home?
0.
Yeah. I know DLC, Daniel's online. Rob, usually you have your hand up. So there's a few folks in here that are familiar with the mesh, been on the mesh, and have used it. So we'll draw them in as well and talk about their experiences. But tonight, what I wanted to talk about was using mesh for emergency communications. One of the things I think we tend to think of with mesh is just a network out there, but the services are really what makes the mesh work. And that's what we're going to talk about. Just by hand here. There we go. Okay, so tonight we're going to talk about Scaries a little bit. South County Aries, it's an organization I belong to. Just the general thought of rethinking emergency communications. We're going to talk about Arden. Arden is really the root of this entire system, and we'll get into that. The history of mesh at Scaries. We'll introduce you to BAM, the Bay Area Mesh. And it's really an entire organization. It's not just this mesh. There is a driving organization behind it. We will talk about what is an amateur radio mesh network, how to get started building your network. All right. The network's already being built. So what we really want you to do is join it. We'll talk about the grant that we received as part of BAM. BAM did get a grant from ARDC, and we got, I guess you would call it a sub-grant from them to get some equipment. So we'll talk about what we did with that. Services that are on the mesh, and what are the next steps? What do we need to do from here? Okay. So Scaries, South County Aries. When I say South County, it's San Mateo County. It's a long history. It started, apparently there was a North County Aries organization, which apparently it fizzled out years ago. So that's why we're called South County Aries, but it's really San Mateo County Aries. Pardon? Yes. We're primarily on the Bay side. We don't have a lot of people that come up from the coast, but we do work with them fairly closely. We do work closely with the various EOCs, Menlo Park, Redwood City, Belmont, especially, San Mateo County. So all the various cities on the Bay side, we try to work pretty closely with. We have the monthly hospital net, which I think is different than what you guys do in Santa Clara. There's a Santa Clara net that is primarily, I know it's on N6NFI. There's another net of many of the hospitals that are in San Mateo County. We do provide communications for various events like the Redwood City 4th of July parade, the Halloween Watch, which was just a couple of days ago. They didn't have it this year, but we help out with that. That's where we go out with the Redwood City Police, and we help monitor the various areas looking for any trouble. And then Silent Night, which is a New Year's Eve event where we do the same type of thing with the Redwood City Police. We also work bicycle races and various runs and walks. And we also do lots of training. So if you're ever interested in any kind of emergency communications training, we usually have something going on every month as far as MCOM training. Right. So when I talk about rethinking emergency communications, one thing we really need to think about is how well are we serving our served agencies? What are we doing for them? Often, I hate to say this because oftentimes what I hear from them is when they see us with our ham radios, strapped to our belts and walking around talking to each other, they think it's kind of quaint at times, but they really don't know what the heck we do. They somehow think it's a little bit antiquated because part of it is we're not educating them. But one of the things that they do understand is they understand things like networks, TCP IP, they understand email, they understand chat, they understand phones. So what we can do to help our served agencies is start to move them as well as ourselves into the 21st century. Next one. All right. Amateur Radio Emergency Data Network, ARDEN. So ARDEN, as I said, is really the heart of this whole system. So what is ARDEN? ARDEN started, I have up here, 2015. So some of you may remember the ham mesh many years ago. Well, it evolved pretty rapidly from there. The ARDEN folks kind of split off, started their own project, and that's what we're working with now. Okay? If you think about these radios, there's a radio right here. It doesn't look traditional. It doesn't have an antenna off of it. There's no speaker, no mic on it. But here, I'll pass one around, Rob. So this is actually, it's a radio and an antenna built into this one device here. And we're not limited to just this one. There are a variety. You can see this dish up here. That's another type of mesh node. And so there are many nodes. So essentially what has happened is the ARDEN folks have taken, essentially what we've built is an ad hoc network. So what's an ad hoc network? It's one that doesn't require centralized services. If you think about the internet, we have DNS servers, you have someone allocating IPs to everyone. You can't just plug in, although you kind of think you do. There's somebody that has to manage all of that. Well, with an ad hoc network, it's all done dynamically. The system itself sorts out as a new node comes online and figures out how it works, or where this particular node is and how it connects, right? Minimal configuration. As far as us as hams, you don't have to be a network engineer to make this work. Actually, it's not quite plug and play. You do need to know a few things, which channel to use, for example, and I'll walk through all of this as we move along. But it doesn't require a degree in engineering to understand how this works and make it work. It's a great platform for services. As I said, we're building an infrastructure right now, but just like the internet, if all we had was the internet and no services on it, it would be worthless. So you need to have things out there like email and chat and VoIP in order to make it actually productive. When they started this project, it was all done with off-the-shelf equipment. There's nothing specialized about it. This is the type of equipment that you would purchase if you are running your own wireless internet, or if you were working for a hotel or a golf course and you needed to be able to serve people throughout a large area. This is the kind of equipment that's in use, off the shelf. All right. One thing about BAM and the ARDEN folks is everybody, just like us as hams, they're all volunteers. Okay, everybody that's testing the software, that's coding the software, all volunteers. So obviously have patience when you are using this software, installing it. It's not going to be perfect, but it's being built by volunteers. Okay, so what how did Arden get started? Well, one of the things I mentioned is this off-the-shelf hardware, but in order to really make all this work, what they did is there's another project, some of you may be familiar with it, it's called OpenWRT, and it's essentially an open source router software. Okay? So what they did is they leveraged that. They said any hardware that's supported on OpenWRT, we can support that. We'll build on top of that. So that gave them automatically a whole new level of support. So on top of OpenWRT is the Arden software. Oh, and by the way, this whole thing runs on Linux. So if you use Linux, if you ever used any kind of Unix system, you're going to be familiar with it. You can SSH from your laptop into your node. Some of you won't know what that means, but essentially it's a way to connect and get in and get to a command line on this node, because just like a Raspberry Pi, it's running Linux, okay, which is an extremely stable platform, by the way. And then on top of what Arden built are things like the optimized link state routing daemon. So that's one of the key systems that does this auto discovery. I was talking about when you hook up to an ad hoc network, how does it know you're there? There's no DNS. Well, that's part of what the optimized link state routing does. And the link quality manager, they go out, and the first thing I do is I start saying, here I am. And other systems start to respond. And we start a communication. And that's how I join the network. There's other software, Tunnel Client, Tunnel Server. That's all built into Arden. You don't have to do anything to make that work. Right. The history of Scary's Mesh. Well, way back when Hamnet first came out, we thought this is a great idea. We're going to skip packet and move right into TCP/IP networking. We're going to jump into this mesh. So we all set up and bought those devices that it's going around. They're 2.4 gigahertz, which now we've already progressed past. But we'll start at 2.4 gigahertz. So we bought tons of these things, and everybody was setting them up at their home. And all of a sudden, we had a network. We had people from all over San Mateo County who could communicate with each other. Unfortunately, that didn't last long. What happened is as new buildings were being built and people moved away, unfortunately, through attrition, or some people passed away, we lost key nodes within our network. And so the mesh started to kind of fizzle. Some people couldn't get connected. Well, about that time, we also found out about this SFWEM, the San Francisco Wide Emergency Network, or the Wireless Emergency Network, excuse me, which then became BAM, the Bay Area Mesh. And we found out they've been doing the same thing that we've been doing in San Francisco, Berkeley, Marin. So they were hooking up all this other huge network. We didn't even know about it. So as soon as we found out about it, we started working closely with them. They had already moved on from 2.4 gigahertz into the 5 gigahertz range. So we didn't scrap all of our equipment, but for the most part, we've transitioned everything over to 5 gigahertz. All right. We did get a grant from them because they had a grant from ARDC. And if you guys don't know who ARDC is, it's the Amateur Radio Digital Communications Group. They are the group that is managing the funds. We had a big allocation of IPs, ham operators. We weren't using them. So those got sold off for, I don't know, millions, billions, some hundreds of millions of dollars. So ARDC manages that fund of money. And if you were at Pacificon, you probably saw a table for ARDC. And what they want to do is they want to give you money. All you need to do is write a grant. Okay. So something you should definitely be thinking about, because they got I think it was $100,000 grant for BAM. And BAM, of course, kind of gave us a sub grant, you might call it. So we were able to acquire more equipment for our club. I asked them before this meeting, is there any more money left in your grant from ARDC that I could tell Para about, and maybe they could write a sub grant? Unfortunately not. So now you have to go directly to ARDC if you're looking to get any more money. I think there was some write-up that just recently about ARDC a couple months ago. I can't remember if Para was talking about it. No? All right. Anyway, our big plan was to get San Mateo County online. So we started looking for locations. One of them was up on Kings Mountain. If any of you are familiar with the Kings Mountain Radio Club, they have their own tower up there. It's right at the fire station up on Kings Mountain. Has anybody ever heard of them? N6ZX, I believe. All right. So we work with them. We also work with some folks out in Portola Valley who wanted to get connected. And so by working with them, we got in touch and were able to find that they already had an agreement with the city of Redwood City to have equipment up on the Easter Cross, not the Easter Cross itself, the Easter Cross water tower. So they already had ham equipment up there. So we were able to leverage that. And I'll get into the more details of what we did. But by doing that, it helped us grow this network pretty quickly. And we started getting these 5 gigahertz nodes into the hands of our members. Right. So what is BAM? Well, I already spoke about it a little bit. They started out as SFWEM. They did get the grant, and they've been helping this whole network grow. If you think about what they do, their organization is really driving the infrastructure of this network. They're not so much interested in setting up email servers or setting up chat servers, although they do have those. Their goal is to get the infrastructure working. And that means they've been installing things on Sonoma Ridge, Black Mountain. They came up when we were installing things on Kings Mountain. So they're working all throughout the Bay Area to get these networks, these nodes installed. Okay? And they really are the driving force behind this. All right, so let's look at a mesh map. Now this is 5 months old, I think, when I did this presentation last. So this, although it looks like there's a lot of nodes out there, there's actually way more nodes already. This thing is growing very, very quickly. But you can see, kind of when we were getting started up on Kings Mountain, they have decided we need to split this because we have so many people on channel 179. So right about that time, they moved everything below San Carlos, everything south of San Carlos, onto channel 175. And so as we were up on Kings Mountain, we had, so here we are, just the peninsula part of the Bay Area mesh. And I'll hold the Kings Mountain thing here for a second because we made some on-the-fly decisions as we were putting those nodes up. So what is a mesh? Well, it's really two or more nodes that are talking to each other. So right now, I have this one plugged in. And there's a little battery down here on the floor, a little BioNO. And in the back, you can see there's another device that looks very similar to this one. And then you have this kind of oddball dish up here. They're all on 5 gigahertz. They're all on channel 175, I believe I put them all on. So there's a mesh. Now, it doesn't do a lot of good to have a mesh in a small room like this. You want to, of course, have it over a wide area. But if I could prove and show how well this works within this room, it doesn't take a lot to move this out and expand it. And that's what's being done right now. Right. So you need to be within range. You need to be on the same channel. And you can see over here, some of the bands, there's 5 gigahertz. You can see how many channels are available on our 5 gigahertz. And unfortunately, the 2.4, there's really only 2 channels, I guess now, -1 and -2 that are available to just us hams. Okay, so not a lot, and which is why everybody moved to 5 gigahertz. Right, so in the interface, the beauty of running Linux is that there is a little web server on this as well. So in order to configure it, I just go to the web server on my laptop, and I could then set the frequency. I could set the channel that I want to speak on, and I also set the SSID. Daryl.
Need to mic that, man.
Do that again. Sorry. He was also saying, is there DHCP? So in other words, how do I get an IP on my laptop? Do I need to set it manually? Absolutely not. All you do is plug into a device to get your IP. Okay. Yes. So each, he's asking, is it a NATed address? And it's a gateway address. So what happens is, by default, I think it is allocated 5 specific IPs. And that's based off of the MAC. And that's what I mean. You don't have to, I don't get allocated those IPs. It takes the MAC and says, all right, you're going to be 10 dot, and it's all on the private network, by the way, the 10 dot network. So by default, I could give out 5 IPs. However, I might want to give out more. I might want to give out 13. So I can change that value and say, I want to allocate 13 IPs. Okay. So, and then this becomes my gateway, right? Just like your home router is your gateway into the internet, this is now my gateway. Okay. So the whole idea of a mesh is that each node does not have to talk to each other. In this room, of course, they all talk to each other. But if this node were out the door, perhaps this one wouldn't be able to reach it. But this one pointing in that direction could. But I could still talk through it because this node can talk through this node, which could talk to another node that's out the door. Okay? So each node doesn't have to talk to each other. I just have to get to the next hop. Now, the more nodes I can talk to, it gives me more redundancy. So if a network goes away, power outages somewhere, the more networks I can talk to, the more redundancy I have. And also keep in mind, these are microwave frequencies. So A, don't look directly into it because it's not good for your eyes. But B, it's highly impacted by buildings, trees, even leaves, raindrops. But what you'll find is you'll do better in the winter than in the summer when all the trees have lost their leaves. So one thing to keep in mind is there's what's called a Fresnel zone. It's kind of a cigar-shaped, football-shaped zone. And it's like this. If I'm blocked, I can still communicate. But that's really the question is, what percentage of my signal is blocked before my connection is so poor that I really can't communicate? They say, 50%. So if this bottom line here is blocked by those buildings, but 50% of the signal gets through, I'm probably okay. So you don't have to have perfect line of sight in this Fresnel zone. Right. So I talked about this optimized link state routing. And that's really the key to making this whole thing work because, like I said, there's no DNS. There's no routers out there that are performing the functions that we're so used to on the internet. This is an ad hoc network. So what the optimized link state routing does is it goes out and figures out how long it takes to get from point A to point B to the next node, and then maybe a different node over here. It takes that and figures out, okay, which one is cheaper? And what I mean by cheaper is just latency. How long does it take? And if this one is faster, that's the one I'm going to use. But keep in mind, because it is a mesh, if this node over here goes down, it automatically knows, hey, I can talk to this node over here and still get there. It'll be a little slower. Okay. And in doing so, it helps build a route throughout the network. And so I now know how to get from my house to Rob's house through the mesh. Okay. And there's nothing that I had to do to program this. I didn't have to set manual routes. So what's a mesh good for? Well, Southern California, one of the things that they did is they started installing these remote nodes throughout the forested areas. And they did that because they could put cameras on them. They could hook them up to solar panels. And now all of a sudden they could monitor these wooded areas. And they were some of the first ones that saw smoke coming from some of the wildfires that were happening, and they were able to report that. So as agencies found out about this, it's like, wow, this is fantastic. Cameras out in the woods all run and can be monitored from a safe location. So they were able to get grants to install more of these. That's just one of the uses. I mentioned bicycle rides, bicycle races that we've all worked. Imagine being able to put some cameras out there, being able to read the bib numbers as riders go by, being able to see where the last rider is, and without having to call out and see. And we still will probably want hams throughout the race course to help. But if you are sitting and being able to just watch that and know where these things are at, you don't have to make as many calls out to see what's going on. Same thing goes with races, road races, walks. But of course, emergency disaster network is what this is called. And that's what this was designed for. So during a disaster, the internet's going to go down. We all know that. So what are we doing? We're building an infrastructure that can remain up. Like I said, I'm running these off of little batteries. This device can run off of as low as about 9 volts. It's supposed to run off of 24 volts here. I'll pass this around. This is a PoE device. By default, it gives you 24 volts. But you don't need to run it off of 24 volts. You can run it down to 9 volts. Okay, so you can easily run it off of a bioenno battery. And I'll show you some of the solutions we've come up with for that. So don't wait until there's a disaster to start building your emergency communications network. Get it built now. Test it. Put these services out there. Use them. We're starting to run monthly chat nets, so to speak, because there's a chat server. There are chat servers all over the Bay Area. We've interconnected all of them. So now what I post on my chat server automatically links and goes to all the other chat servers without me having to do anything. It's a web-based chat. It's not, yeah. So you just go and give it your call sign. There's no passwords. Everybody's trusted because we're all hams. So you log in with your call sign and you're on the chat, mesh chat. And mesh chat can actually run on the nodes. It's a small little app that you could actually install and run on your nodes. I'm running mine on a Raspberry Pi, but you don't have to. Okay, so I spoke about when you have a mesh having redundancy. And so what exactly happens when a mesh node falls out of the network, right? So we look in the upper right, somebody had a power outage, the battery died, something happened, the node has disappeared from the network. But you can see it, the network is self-healed. It automatically went out and said, okay, that one's gone, that's okay. I'm now going to communicate still connected to the mesh through a different node. Okay. So once that connection comes back up, it doesn't have to do anything. It automatically rejoins the network without having to announce it. It just rejoins. All right. So how do you get involved with mesh network? What do you need to do? Well, they have recommendations on the BAM site. And you can see right down here at the bottom, this QR code if you want to take a picture of it to get there. So this is some of the equipment that they're currently recommending. For people that don't do networking a lot, you probably, even if you don't know and haven't done it a lot, there's 802.11, 802.11a, 802.11b, 802.11g, 802.11n, and each of these got faster and faster. So for probably, I would say most folks in this room, you're probably running 802.11n. You don't even know it. If you bought your router within the last couple of years, your wireless access point, you're probably running 802.11n. Well, the next big thing is 802.11ac. Equipment is, it's actually becoming easier to get AC equipment than N. So the recommendation right now from BAM is to buy AC equipment. If you have N equipment, that's fine. They still talk to each other, just like your old laptop can still talk to your newer router. The same thing goes for 2 nodes. AC node talks to N nodes. Not a big deal. The BAM folks are trying to get AC installed on any of the backbone nodes because that's going to give us the highest throughput. And so if you're going to go out and buy something, buy an AC. You're, as it turns out, you're probably going to end up spending more money for an N node than you would for an AC node. But there's some caveats. The latest version of the software is the only one that supports any of the new AC equipment. So prior to .8, which is what we're all on, there was no support. The nightly builds, experimental builds did, but the builds that the stable builds did not. And with .8, the stable builds now support AC, but not a tremendous amount. Right, so here's the Ubiquiti N5. So this is what I'm talking with here. There's a new Ubiquiti 5 AC. Unfortunately, it's not supported with the stable build, with the current build. You can use it with the nightly build. So it's kind of a use at your own risk. Other thing that we're finding, and this is a caveat now, is that because the these I just told you go down to 9 volts, so it's ideal for our 12-volt environments. Unfortunately, the AC equipment that we're seeing out there needs maybe 14 to 15 volts is its bottom number. 24 volts is what it runs at normally, but it only really works down to about 14 volts. So this will become your friend. This is a 12 to 24 volt up converter. They're cheap, 14 bucks. It gives you nice, stable 24 volts out of your 12-volt battery. Sorry, power over Ethernet. So power over Ethernet means that I don't have to plug this into anything other than Ethernet here, and I can run this up to my roof. I don't have to have a separate wire. There are 2 pins, positive and negative, that provide power over Ethernet. So the little black box that I passed around, that provides, so that provides 24 volts power over Ethernet. 12 volt, you can just get these little PoE injectors, power over Ethernet injectors. Plug one end into a battery, plug it into the 24-volt device, and you can get from out of here power over Ethernet. Thank you, Darryl. But sometimes we throw those things out there and forget that not everyone has been doing this. So MikroTik has a device. Now notice this device, actually the one on the right, notice that device is a separate radio, which is the Ubiquiti Rocket. And there's also the Rocket AC, which is supported. And then there's a sector antenna. The sector antenna that you buy for your old Ubiquiti Rocket also works with the new one. So it's a 5 gigahertz sector antenna. This one is 120-degree sector antenna. You can get a 90-degree, which just means coverage. 120. So if you look at the cell towers out there, you often see these sector antennas. You see a whole array of them. And that's essentially what you have up here. And here it is. There's our lowly PoE device, power over Ethernet. Notice that one side says LAN, one side says PoE. So the one that says PoE, that's the one you plug your node into. And the other one that says LAN, that's the one you plug your laptop into. Okay. So that device runs off of AC, not battery, or the PoE adapter. That's your LAN. You can plug your laptop, your tablet, what have you. Or if you want to share it, you can plug a wireless access point or another router into that. And now my laptop can connect to that. My phone can connect to that. Everything can connect to that wirelessly. Because, well, with the exception of a few devices, you can't connect to them wirelessly. You have to connect to them through a wired connection, unless you put your own little router there. Okay? Yes. Well, not, I mean, they could get onto your home network. I mean, they can get into your home network through like a VPN connection or something. Then, yeah, I mean, sure, they could always get in through into the mesh, but it really depends on how open your side is. If I hook this up right now through the magic of telephones and such, I'm actually hooked to the wide mesh, and I'll show you a little bit more and I'll do a demo. But right now I am tunneled in, which means it's like a VPN connection. I'm hooked in from this little device. I'm hooked in to the rest of the Bay Area mesh through my phone, which is now basically acting as a MiFi device. Through that, I'm talking to one server that's up on Kings Mountain and talking to another server that's in Redwood Shores. And so I'm now tunneled in through those. But you can do that, especially when you want to go in through, quote, a tunnel server. You want, what a tunnel server, all that is a way for me to, if I can't talk from my house to another node via RF, node to node, I cheat. I connect through the internet. So when I say I tunnel, I'm basically tunneling through the internet like I would do with a VPN connection. So this is connected to some other device that has many connections via RF. And now it's just like I'm on the mesh, except of course during a disaster when the internet goes down and I won't have connection.
I'm going to ask Clark to repeat that so people on Zoom could hear.
I have my setup at home. I have a computer in between the mesh network, my home network, with ports into both. And that way I can VNC or SSH into that computer and then see the mesh from there. So I can, at home, I can just use my laptop or something to access that computer and then see the mesh. So I don't have to go to that computer to access it. But there's no other connection between the two. There's no software that runs the routes between them or anything like that. It's isolated in that way.
Margaret, did you? Oh, yes. Hey, Ed.
So you had it hooked on to another wireless router, but if that wireless router is the ordinary, 2.4 gig 802.11n or G,
It's
wouldn't other
commercial.
people be able to pick up that signal then?
Yeah, well, just like they could pick up your home signal.
Right.
Right.
So, okay, I have a regular router, that's hooked on to Comcast. That's running.
Mhm.
I can run this in another channel. That's okay. And you would log on this just like your regular router.
Yeah, password protected.
Your password protected. Yeah.
Well,
Your password
just
protect
like-
that router. Yeah.
yeah, just like at home.
Yeah, just like your home.
somebody can't drive by and just connect to your router.
Right,
You have a password.
Right.
Same thing here. You put a password on it.
Yeah. So
And
you
you-
basically transfer the 5 gig stuff down, put it into a 2.4 gig router, and you're okay.
Yeah.
Hmm.
Exactly.
Yeah.
Or you're one of those that just leaves everything open.
Oh, that's not on my laptop. We need to take the 2-hour break. Oh. Okay. Keep moving. Looks like somebody got that off. All right. So how do I hook up multiple nodes? Well, you saw hooking up two things through the simple PoE device, but you may have a half dozen nodes at your house, for example, especially if you're trying to experiment and test. Well, you could hook them in through a simple unmanaged switch. Right? Now, if you're into networking, you went out and you bought a managed switch, then you're going to need to set up VLAN 2 and say this port 1 and port 2 are on VLAN 2 and they can talk to each other. But if you just go out and buy a simple unmanaged switch, a quote dumb switch, they don't care. They'll talk. All ports will talk to all the other ports. Okay. So that's the easiest way. For us, yes. Is VLAN 2 hard coded? Yes, and we do use VLAN 2. Yeah, you kind of have to know. But you don't have to. Just buy a dumb switch. Don't try to get fancy. All right, so here you have a dumb switch at the bottom. You have these devices all connected, and you notice they're connected device to device, DTD. So what does that mean? All that means is this node is talking directly to, let's say, this node, not through RF, but through Ethernet. They're hooked together via Ethernet, and that's considered DTD. All right, device to device. You'll see some of those when I do the demo. Next up, you can also hook in and bridge networks. So Ed was asking about, okay, if I have 2.4 gigahertz on my home router, what if I had a node? So the other node over there was a 2 gigahertz node, and this one's a 5 gigahertz node. Can I make them talk? And yes, device to device. Hook them both in through a dumb switch, and now all of a sudden they're communicating with each other through Ethernet. Okay, so I passed around some of these PoE injectors, power over Ethernet injectors, so you can kind of get an idea of what you could use if you want to do it through batteries. Okay, you don't need that black box that has LAN and PoE on the other side. This is kind of the same, same kind of concept right here. One side without PoE, one side with PoE. Here's where you inject your 12 volt or 24 volts. Okay. Now it's all up here. So how would you hook this up to solar? If you wanted to be able to run a node without having to worry about the grid power and the grid going down, you could set up something like this. So this is a little panel. I did it with a 50-watt panel. I've also tested this with a 25-watt panel, some generic MPPT, maximum power point tracking, charge controller. I prefer the Genasun, but they are a bit more expensive, granted. Look at that, 4.5 amp hours. It's a very, very small bioenno battery. I do prefer 6 amp hour batteries for this, but you can go down that far. There's also these talent cells. They are lithium ion. They are 3S, meaning that they're 3 18650s hooked in series on this. So it gives you roughly about 12 volts when they're fully charged, down to about 9 volts. But if you're going with AC equipment, I would stick with bioenno. I'm going to draw for a node like this about 0.23 amps. Okay, very low. If you go up to a rocket, which was, remember I was showing you the rocket hooked to a sector antenna, that's closer to about 0.4 amps. Okay, but for most home installations, you can get by on fairly low power, 0.23, 0.25. Yes. Yeah, we can get, a couple watts out of, some of these things. So yeah, way more. That's why I was saying, don't look directly in as where it comes out. It's microwave. Here's a connection. Here's a connection using a bioNO with a Genasun 24-volt up converter. Now that you might have to use that. There's different here. Ubiquity, and if you do networking, especially for work, you're probably familiar with the name Ubiquity. You're probably familiar with the name MikroTik. But let me pass this around. So this is some of the equipment that they sell. So as you're determining how you want to hook up your devices, you can go very simple, and that's what I've done on mine. Some people want to go almost like a professional installation. So one of the devices that's being passed around is 24-volt out. It's meant to hook to two 12-volt batteries hooked in series for 24 volts, lead acid. And that's just because of the way its charging algorithm. When it was designed for lead acid. All right, back to the grant. So we were given 40 of these nodes, and we installed them as many places as we can. We still have some members who have nodes who haven't put them up on their roof yet. We're working with them as often as we can to get those done or to return them, because we have other members who didn't get one and who now would love to get them. They're not expensive though, by the way, $87. I think when we bought most of ours, they were like 75. So these things are not expensive, but if you can get it for free, might as well. We got some power beams. We got a big spool of cable. We got some cameras, and we also got 2 rockets and 2 sector antennas. Here's some of our members' installations. Right, Kings Mountain. So if you know Woodside, Kings Mountain is sort of the peak of the hill going to the coast. It's off of Skyline. And that's the Kings Mountain tower. We'll get some better pictures. But what I meant by we kind of made audible when we were up there, initially, we were thinking about putting 2 220 degree sector antennas pointing kind of northish and southish. But Frank, N6YP, sent his drone up to where we were going to be installing this on the tower. And we realized we only really have about 90-degree view of the valley. So putting 240 degrees of mesh out there was kind of a waste. So we put 120-degree sector and rocket and another just below it. And why would we do that? Well, we set them onto different channels. Remember I told you used to be all on 179, and then they made 175. So this was an ideal place to connect those 2 networks up. So that's what we did. We hooked So south, we see Facebook. North, we can just see the San Mateo Bridge. So that's what the installation looked like. 2 sector antennas and then a camera that sits at the bottom. There I am climbing the tower. No. What's that? Well, you'll see. But you can see over there to our left, there's our nodes. Have them circled. There's our tower climber. You see why I didn't climb. It is pretty tall. Also, I guess it's an old military tower, and there's no horizontal, well, steps, rungs. They're all diagonal all the way up. So imagine climbing this thing with no horizontal steps, rungs, having to climb, and then having to stand up there for hours as he's installing this stuff with his feet kind of off like that. Yeah, he earned his money. So what did we get? What did we get out of it? Well, there's Kings Mountain, and there are just some, because like I said, this was done a little while ago, but you could see we immediately started making connections out into San Mateo County, out all the way. We actually have been making connections across the bay. And Rob, I know you connect to this. Yes. We have any notes? We don't, because there's so many trees. We don't have anything hooked up. Now, I could talk about one of the things that's going on. There's a project came out of a guy out of France on 440. He's doing TCP/IP over 440. We're limited by our current bit rate, so it's fairly slow. I saw at Pacificon that that's one of the big things that's being pushed through this year, is to increase our bit rate. So that'll be fantastic. If we can go to its maximum speed, we can actually hook them up via 440 and be able to communicate. Pardon? It's TCP/IP over 440. So it's not, quote, mesh, it's just a transport. So from their laptop, he would be able to essentially connect into the fire station.
Rachel,
Yes.
there are 2 nodes there to the northwest of Kings Mountain.
Yes, those are tunnel. One is Frank's house, and one is Bill's house. They both have one of these. This is a microtip tick HAP, HAP, and they're tunneled in so that they can get to the fire station and manage that node. How far south? From what we could see as far south as Facebook, which is Menlo Park. But we came up with a new solution. Yes, Frank.
I asked Jerry Michaels, as 2 or 3 up there at his residence. I just wondered whether you had a mesh net up there. I hadn't asked Jerry whether he did or not. There's Jerry Michaels has 2 or 3 repeaters up there near the firehouse. And I was just wondering if there was a mesh net up there, but I guess there isn't.
It's not at the firehouse?
No, it's not at the firehouse. It's private residence across the street and up the hill.
Oh. So perhaps, they could put a mesh node up on, if he has a tower there, you should be able to easily reach the Kings Mountain Tower. Yeah. There are nodes that are further south than that. I mean, we have Kristen is hooked up from San Jose. But she's tunneled in right now. We hope to get her hooked in through Black Mountain. Pardon? Yeah. Oh no, there's definitely there's the, what is it, W6EI, the fire station that serves a great deal of Santa Clara. 5. I think it's on 171. Yeah, 171, I think, is what they're using. But they also have a node that's pointing more towards us that I think is on 179. And again, Ed? Well, through the mesh. Yeah, we can get to it through the mesh. Not direct, not, yeah. Okay, so continuing on, the two nodes hooked together, DTD, device to device. You can see when you look, and we'll look at the current mesh status, that as you go down, you have your estimated transmissions. So all that means is how many hops do I think it's going to take, or how long do I think it's going to take to get from point to point. So as you see, the further you go down, the bigger the number gets. So that's how it's sorted. When you're looking at this, nodes that are fairly close to you, that you're going to have a pretty good chance at making connections to, are going to be at the top. And the ones as you go down, they may be in Marin. You're never going to make an RF connection to them, but there's a good chance you could still connect to them. If they have a service, a camera, you might be able to get to them, just depending on, you know, all the links are good, and view their camera. So the camera that we have up on Kings Mountain, once in a while I go out there and I do a screen capture and grab some pictures. There's a night view of San Mateo County, a foggy view, morning fog. Daytime. There we go. All right. So next project, once we got Kings Mountain connected, we really wanted to get the Easter Cross. 2 reasons. Folks in Portola Valley actually have line of sight from Portola Valley up to Emerald Hills Easter Cross. If you haven't seen the Easter Cross, you should take a drive up there. It's a very windy drive to get up to the Easter Cross, but it's very cool once you're up there. You can't actually get to the water. It's all locked off. It's gated, but you get a very beautiful view of Redwood City. So we put 2 nodes up there. We put one pointing 90 degrees, which is kind of right towards Menlo Park through Redwood City, and one pointing about 168 degrees to Portola Valley. So the folks in Portola Valley who really didn't think they were going to have any chance of getting on the mesh now have beautiful signals. They're both hooked in with parabolics, not unlike this, a dish, pointing to our nodes, which are just, right now, they're just these nano stations. Our plan was to put sector antennas and rockets with higher power. The problem, on the water tower itself, there are railings. And what we would need to do is to hook a new mast up in order to put these rockets and sectors, because they're big. They're fairly large. These, we were able to just zip tie onto existing masts that the Portola Valley Radio Club already had permission to install. But they said if we wanted to put some more masts up there, we would have to go through an entire engineering study. There we go. So there's the water tower, round thing there. You notice this building next to it and all the microwave that's up there. That's part of the reason why you have to get an engineering survey, because we want to make sure that we don't interfere with other people. There's so much commercial microwave up there right now. The picture up on the right is the view into Portola Valley. And the one on the bottom is the view into Redwood City. And there's Larry, W6RMF on the right, and Ray, who helped install this. So the first installation was a little bit ghetto. You could see there's a, what is that, a 7-gallon aquatainer sitting on, on the pad right there. So what we ended up doing, we didn't want to just start installing equipment. We wanted to make sure, do a proof of concept. So we put 2 mesh nodes up on a 15-foot mast, and we use those. You've seen them where you drive your car tire up on a mast holder. So we basically just put a 7-gallon water container there to kind of weight it down, and then use paracord to rope it off so that it wouldn't fall over. But it worked beautifully. It worked great. So the next step is, you can see that little kind of ladder to the left there. Climb up there, and Ray went ahead and installed those up on the water tower itself. So we even have better connections now. They have emergency power up there. I was really surprised, but yeah, they have emergency power. It actually comes out of that utility box that you were seeing that we're standing next to, and we get power over Ethernet out of that box. Yeah. So DLC is up there, and Dan is now connected. I know Dan's on the call, and who is that KC6TYD guy? So Rob has been making connections to the Emerald Hills as well. Imagine, rather than having to call the hospital and say, listen, we need streptomycin, we need
Whatever.
some list of prescriptions that you're going to have to go through the whole I spell and spell it and then repeat all after, because nobody's going to get it the first time. You talk to them on the phone, or even better, you could email it to them and say, we have 10 people at the shelter who, these are their prescriptions, we need to get these filled. And you could just email it to the hospital. It's going to be so much more accurate. Are we good, Rob? Okay. So back to where we were. That's Portola Valley. We're going to start moving pretty quickly, guys. This is some of the things that we see with the various networks. All right, services. I'm going to go move through these pretty quickly. Remote cameras. Mesh maps, offline Wikipedia. Imagine being able, internet's down, being able to use Wikipedia, because I have the entire Wikipedia on a Raspberry Pi, and you can access it via the mesh. OwnCloud. Imagine Dropbox. OwnCloud is like Dropbox. Same beautiful interface. You can now, I've downloaded every Yaesu, every ICOM, every Kenwood manual I can get my hands on, every first aid document. I have hundreds of documents in a repository on OwnCloud. And once again, imagine disasters occurred, you're trying to figure out how to program your FT60, you've forgotten what you need to do, you could download the manual off my Raspberry Pi. Email servers, we have chat servers, voice over internet, as you just saw.
Questions first, since they haven't had a chance.
Let's move along. There's Wikipedia offline. There's this is what Dropbox looks, OwnCloud looks like. There's some Yaesu manuals. Team Talk, just like Zoom, it's free. You can download, and even has a app for your phone. So you can do Team Talk off your phone. Email servers. So imagine it's been a disaster. You're out doing a survey through your neighborhood. Pull out your phone. You see a house that's fallen off its foundation. Take a picture of that. Send it via email to the EOC. You don't have to call in and try to describe it anymore. Take a picture. I have Citadel, once again, installed on a Raspberry Pi. This is webmail, but you could use Outlook, anything you want, because it does talk POP and IMAP, supports submission port. So it's not just socket 25, 587, all the things that a modern mail server supports. It's supported in Citadel.
Address would be your call sign. Totally independent computer.
Yes, it's completely internet. Well, so you sign in. I sign in KK6DAC. I'm KK6DAC at RP01, I forget, whatever, local.mesh. Here's the chat server I mentioned, where we're doing monthly chats now. So once again, you just sign in with your call sign. Citadel does have its own chat as well that you can use, things like Astra chat, do chats. Here's PBX. And you don't have to do PBX, by the way. If the PBX is like way out in the middle of nowhere, you can do direct IP to IP phone dialing. And you're just doing direct to direct. All right, what's next? Well, here's Palo Alto, Menlo Park, Redwood City. Come on. All right, we've gotten permission from the Menlo Park Fire Protection District to install nodes on every fire station. So that gives us 6 more nodes that we'll be installing. So these are a map of where Scary's members are. We need to get more nodes in our members' possession. There's the fire district. Perfect location, Stanford Dish. So I've given the same presentation to the Stanford Radio Club. We have tentative agreement that we're going to be installing at least 2 nodes up near the dish. So that will cover a great deal of Palo Alto and South. All right, so rethink emergency communications. Bay Area Mesh, tremendous amount of momentum right now. So you really need to get on board. The more mesh nodes we have, the more resilient our network becomes. Okay, and your served agencies are going to love you when you start showing them these type of things. A VoIP phone, there's voicemail built into this little box here, so I can call and leave voicemail. So come and join us. Here are some links, things like SFWEM, which is BAM. There's the mesh map, which I can probably show you. So this was the demo I was going to do. We probably don't have time, but essentially I have my phone hooked up and we're on the mesh right now. So this whole time, I haven't been accessing this through the Palo Alto, the thing that Rob's using, the local one here that you have to reboot after so many hours. I'm actually hooked in through my phone and connected to the mesh at this very moment.
Can you go back to those links?
Where to buy? There's a company, I think they ship out of Arizona, Streakwave. If you don't know Streakwave, find Streakwave. Streakwave.com. I think they have offices in San Jose. Best place to get network equipment. Streakwave.com. Streakwave. All right. We're gonna end it there, except for questions. Oh,
Okay, I think in order to give a little bit of fairness, I know we have some more questions in the room, but we're gonna go to Zoom people first, since they've not had an opportunity to say anything. And we'll see what they, no Zoom questions or comments or anything?
We can, there we go. Anybody in Zoom, let's get you going here. We've been putting a little chat notice there if you've got something to chat it, but let's open it up. Nobody?
No questions from Zoom?
I've got one.
Okay, Doug, go ahead.
Thanks. Rachel, I'm in San Martin. How far south does this effectively reach?
well, not San Martin.
Not yet, anyway.
Well, okay. How
You-
far
you-
would I have to
you
reach?
could-
to
You
hit
could tunnel in, but I'm not saying it's never going to get there. I mean, imagine right now we're hooked into Marin, so it's not impossible. We will need to get some more connections. Like I said, you know, Kristen's down there around the airport area, and she's kind of all by herself. So we need to get more nodes down there.
Okay. All right. Well, if you get this far south, I'll put up a tower.
Okay.
There is a question from David. How would you know if the mesh partitioned?
I want to know whether the mesh partition.
Actually, Dave, if you want to reiterate that, go right ahead.
Sure. Can you guys hear me okay?
Yep, go ahead.
So the mesh is always supposed to stay connected because it's got a lot of redundant connections. But what if something goes wrong? Maybe a software bug, maybe a cut point, and the mesh separates into two separate pieces that are not connected to each other. How would you know that?
I could no longer see or reach any of the nodes beyond the point where they were routed through. The key here, though, is redundancy. So if one node that was providing that, Sonol Ridge, went down, we would have another way to connect.
Sure. But if you run the same software everywhere, and I imagine you don't, then a software bug could do something like that too.
Yeah. If I can't go, we don't have enough time, but I have to tell you that there's some really smart people that have been working on this. There were issues with network storms, primarily caused by OLSRD. One of the guys, Tim Wilkinson, spent a lot of time solve that problem. One of the things that with this next release, which should come out around Thanksgiving, there's going to be these super nodes. And what that means is the Bay Area can connect to Oklahoma. It can connect to New Jersey, but the two nodes don't have to, the entire networks don't have to see each other. We can get to them through links, but the super nodes protect the individual networks from getting slammed with all this traffic that they don't need. So that's coming out, like I said, around Thanksgiving. We can connect into Hawaii. We can connect into wherever through super nodes.
Okay. I want to let you go on and take other questions rather than keep challenging. Thanks a lot. Appreciate the talk.
Thanks, Dave.
Keep in mind, David, nothing is infallible, okay? If an earthquake happens and everything crumbles to and dust, then we're not gonna need a mesh network.
I see Joe waving his hand. Joe, go ahead, and then we're gonna take any last questions here in the room. Go ahead, Joe.
Yeah, can you run it on a 32-bit system? And if not, what's the minimum Raspberry Pi it'll run on?
It doesn't actually run on the Raspberry Pi. Your services runs on the Pi. Arden runs on these nodes, which I know you can't see that I'm pointing at, but it runs on these network nodes that are running Linux.
Oh, okay. So you're basically running servers on a Pi.
Yeah, I'm running, I have web servers running on the Pi, I have mail servers running on the Pi, and they're connected to the mesh, but they're not the actual mesh nodes.
Okay. So all that's all in the hardware.
Yep.
So you get a lot of bang for your buck for $80.
Oh, a tremendous amount. Daryl.
How do you flash, like when you said there was new builds, what's the process to flash those radios? Flash those
It
nodes?
used to be easier. A lot of things have changed, but to get things onto these nodes, Ubiquity, essentially you have to hold down the reset button while powering it on. 45 seconds later, it goes into TFTP, a trivial FTP server, and then you TFTP the first build, first time only. Then it restarts, and once you've done that, it's all through the Arden software, the web interface. Do your upgrade that way from then on.
All right, Dave.
Okay, I've got several questions. I'll try to be quick with them. Okay, first of all, this is great tools you have set up here. No doubt, wonderful tools you've got set up here. And it can, as I understand it, you can communicate with a whole bunch of people on MOS. Okay, and just saying that in general, you can communicate with everybody everywhere and so on and so forth, doing various techniques, various tools, various methodologies. First, I want to find out if you got a bad player out there, can you cut them out of the mesh?
Yes.
You can unjam a jammer. In other words, you can get them rid of them.
Yes.
Okay, that's easy to do?
Yes.
Okay, good. Okay, the other couple other questions here. Okay, is you said nothing about training. Okay, and what I'm concerned about, I understand. Okay, there's ICS, there's the NIMS, there's FEMA, there's a whole bunch of training out there. There's formal training that interface with the police, fire, and all those full timers out there. And I can see a whole bunch of being interested people having their little their mesh network set up at home, and there's a fire down the street, whatever the heck it is. I'm not discounting that for communicating, but you've got a whole bunch of people out there talking to each other, and there's no, there may or may not be any control. I know you've got some nets going for various bicycle events and so on. You give examples, but I'm just saying that you have a major emergency, you got a whole bunch of people trying to put out their traffic to everybody else. And you haven't mentioned anything about formal training. And I'm really concerned about formal training because, from my understanding is if you're a ham radio operator, a highly experienced ham radio operator, and you show up in EOC, they'll say, okay, go get us coffee, because you don't understand those forms, formats, and tools that they use every day to communicate in an emergency. So I'm saying this is a great tool here you've got set up. But what kind of training, formal and informal training, does the county have set up to allow the communicators to actually communicate using tools that will get the job done? When you're talking about emergency, I saw a whole bunch of stuff about network stuff here with me today. I appreciate that. Nothing about emergency training or emergency management or any of that kind of stuff, which is what I think makes it work. And I can understand 100 hams out there saying, oh, emergency, my house fell down, major earthquake, whatever it is. And, it's just chaos. So I appreciate what you're trying to do here. I would emphasize format, training, education for the hams, and anybody's going to use these tools in an emergency. I would emphasize looking and focusing on that. Yeah. You don't mind me saying that.
And so one of the first things we've already done at Scaries, and more than willing to share this with other organizations, is exactly that training. We set up the equipment. Some people were a shelter, some people were EOC, some people were hospital. What's the protocol? How do you communicate with them? What's the way to do that? And so we've started those steps, but keep in mind the mesh is still being built. So things are not like if you set up a mesh node today, it's unlikely, depending on where you're at in Santa Clara County, it probably won't connect to very many people. That's just where it's at. Until you get more people and get interconnect, just like the internet. The internet at one point was 10 people. Now look where it's at. So that's what the goal is to get all of these things interconnected. And that's what BAM has been working on is getting the infrastructure built. Yeah. Then step 2.
Two questions. Fremont, yes or no?
There's a node that just went up out there in Fremont. I know it's been hitting the folks in Portola Valley. So there are nodes that are going out in that area. Yes, definitely.
Second question, more nodes needed, yes or no?
Oh, yes, absolutely.
Got it.
I've got an invite.
Okay, get it up.
All right.
Right. So the first new question from Zoom, Misha, AC6Y. A couple questions on interlinking with non-HIM equipment. Does communication between the mesh and the internet occur solely via tunnels, or are there services on the mesh available to internet clients? On the flip side, can nodes that are connected via the mesh connect out to reach internet services? Or are the mesh and the internet kept strictly separate except for the tunnels?
So we discourage anybody from creating a open network, an open gateway like that. So yes, really anybody that is hooked up. I think there was one out of Berkeley that was hooked in as a gateway. People suggested the person take it down. I don't think it's up anymore. But from that standpoint, yeah, we're not really looking. I can get into this whole thing about HTTPS, SSL, TLS, encryption, and what we're, as hams, we're not supposed to be doing any kind of encryption. So you can't really reach anything outside, anything on the internet that's not HTTPS anymore. So we can't allow that into our network because that's encrypted traffic. Now, reality, that's what we're doing right now. People are setting up services that are using SSL and TLS because we haven't gotten clarification from the FCC. Is that illegal for people using ham equipment to use TLS and SSL? There was some winks and nods saying nobody's going to go to jail for it. But we would hate to build out this entire network and then somebody comes and say, okay, you need to roll all this back. And all the nodes that are connecting, they're not connecting with TLS or SSL. Everything is unencrypted. But what I'm talking about, when you set up a server, for example, on a Raspberry Pi, and you set up your first time you set up a web server with HTTPS, you're not supposed to do that. Okay? So I'm finding it as I'm setting up these services, it's almost harder to turn off encryption these days because it's so many places, and it self-discovers certs in there and says, oh, you want encryption because you have this cert installed. Then you got to find where that's out, delete it. It's really a lot of work. And so we do need to get clarification. I've hammered or Kristen about this and the BAM folks. What are we doing here? So
there's one more Zoom question.
Hang on, Frank.
All right. So David W60H asks, the bad actor question is good, but if it's too easy to isolate a bad actor, can a bad actor isolate good ones?
They could isolate themselves. But they can't. So some of this is done by the BAM folks. They can do this. So it's not like general knowledge. But the BAM folks have said, yes, we can cut somebody off.
How is identification over the frequency done?
So when you create a node, you create it with your call sign. So this is KK6 DAC-nano 5-01. That's KK6 DAC. Everything of mine, this, everything that I set up is KK6 DAC something.
And what frequency range is this being done?
Well, 5 gigahertz on this, but we could do 2.4. We do, apparently there's some 3 gigahertz still out there.
Yeah, regarding the security that you discussed before, are people expected to run their own like DNS servers or is
no DNS? It's
then
ad hoc.
Then for example, if I want to reach your email servers or like your Wikipedia or something, do I just have your record or?
So when you see, this is why the demo would have been great. If you go into mesh status, there's a big button on the front page, mesh status. You see all the services. You see the node server, KK6 DAC Nano 01, and you see all the services that I publish. So you see my email server, my chat server, my Wikipedia server, my own cloud server, and you can click on those to get to them.
And do you just have like a static IP address once you're set up?
Yeah, so essentially the IP addresses are allocated, like I said, through the MAC of the device. So you get 5, I believe by default 5 or 6, and you can expand it to 13 or up to 20 something IPs that are static. And so of those static IPs, once I make a DHCP connection, I can actually take that IP and say, make that static to this device or to this camera or to something else. And then my node says, okay, that is now owned by this MAC. And then from there, you can publish that. So if you set up a service, you can say, okay, it's an HTTPS or HTTP server, and here's the URL, and that's how it gets published so that people can see what where my node is, or what my services are that I'm publishing.
I see. And then I assume like all of your ports are open, but by default.
Yes.
As you mentioned in the beginning, one of the frequencies is the 900 megahertz, reaching
Yes.
a 902. But yeah, of course, the bandwidth isn't as wide there. Because if you were to go there, the range would be a lot further, for sure, than 5 gigs. So anything in the 902 region that you're working on?
I think the hard part right now is getting equipment.
Yeah. Not a whole lot of people make equipment. That's true. The 5 gig stuff is really available.
There was a time when Scary set up a link across the bay.
Yeah, I mean, 902 propagation's decent.
To Berkeley.
Yeah.
On 900. And it was great. But you can't, Ubiquiti doesn't make equipment anymore. Microtech doesn't make the equipment anymore. So if you find some legacy equipment,
or else pay a lot of money.
Yeah.
Oh, yeah, that's it. Yeah, because I know the propagation obviously much better at 900 than at 5 gig.
Right. It's a bigger Fresnel zone.
Yeah, much bigger. Yeah. Well, that's too bad. But so I've got a bunch of 2.4 equipment at home, which I never was able to get on. Okay. So I mean, it's not a problem. This is cheap stuff, right? So it's easy to just get it. So I'm going to have much better success doing the 5 gig than I should.
To get onto the network. Yeah. So, but what folks like the Sequoias is one of the locations out in Portola Valley. It's a retirement home.
Mm-hmm.
So because we had so much 2.4, it's like, oh, well, let's just wire up the Sequoias in 2.4 so I could reach this anywhere I want.
Yeah.
But then bridge that to the 5 gigahertz, which then goes out to the rest of the mesh. So repurpose it where you can.
Yeah, so I burnt down, my Ubiquiti, I reburned it to channel 1 or what, I forget what it was. It was a separate channel. It's a standard commercial grade router. Okay. We raised the power and then defaulted it, but I couldn't reach anyone from my house. So I kind of gave up. This is like 3-4 years ago. But you're saying I've got much better success. So I'm going to try this out.
Yeah, Black Mountain, they put up nodes. So yeah, there's more out there today.
Consider me another member.
Okay.
All right, we'll take one more question from Zoom and one last one from the room, and we're gonna wrap this up.
All right, Mika, Misha, AC6Y asks, great presentation. Thanks, Rachel. If there's time for one more question, does the network allow only wireless links that use licensed ham frequencies, or are nodes allowed to connect to the mesh via unlicensed frequencies too?
So yes, they, for example, in 2.4, there's more channels available, but it's so noisy. It's a waste of time. Now, if you have some channels in the part 15 range that somehow are available, you can, the software allows you to use those. It doesn't restrict it into the ham frequencies only, but it's so noisy because everybody has 2.4 and 5.8 in the consumer side, the part 15 side. Hey, Misha, and thank you. And you're welcome. Oh. Oh, I see. I see what you're saying. And not use your call sign, not be a ham.
I'm a non-ham and I somehow through tunneling or whatever get into that network.
So this is a very good question because, well, it's not legal because they're using too much power. They're going to be using too much power because through the Arden software, it can talk to the radio and tell the radio to use maximum power, which, you know, people were going into OpenWRT and doing that hack themselves. And that's why it's become so much more difficult to install things like OpenWRT and Arden onto these nodes, because they almost put OpenWRT out of business by saying people are doing things illegal. They're jacking up the power and they shouldn't be. So that's one of the things. But we had 8, 10, 12 channels in 5.8 that were pretty much, well, they weren't dedicated to us. They were dedicated to, I forgot somebody wanted these and we were secondary, but they never used them. So for all intents and purposes, we were primary on those 170 to 187 or whatever it is. The FCC said, these guys aren't using it. So they've opened that up to part 15. So, well, it's the same thing as us using channel 1, channel 2. It's going to be noisy. That's the thing, is we have to be careful because we are secondary.
Yes, the other question, network and the regular internet.
Well, okay, yes. So through this device, I'm tunneling, right? One port 1 is dedicated to an internet connection. So I'm currently hooked into my phone, which is just hooked in through, well, I don't think I have 5G here, but probably 4G. So it's hooked into the Verizon network. And I'm tunneling, but through this same connection, I can go to Google, I can go to Yahoo, what have you, because I'm really talking to this device, which now has an internet connection. It doesn't mean everyone else in the world can go through this connection and get it, but because I'm talking to this device, I can get to it because it's letting me route that traffic. Yes, that's legal.
I'm talking about ham, but the website, whatever it is, let's say eBay.
Yeah, eBay.
It's not a license.
Right.
Could you make the transaction?
Yeah. Because I'm not doing that through the mesh. It's this device is routing me both to the internet and to the mesh, but I'm not doing them simultaneously. I mean, I may have a window open that's to the mesh. I may have a window that's open to eBay, but there's no traffic that's traversing that on this device. That's the beauty of this device.
So I guess I'm a little confused. So eBay talks back to you.
Right.
You're on this network. which is a licensed network, let's say I'm WB6IQN, they just went through eBay going through this network using WB6IQN. That's legal.
Not through this network. It didn't go through the mesh. It went through this HAP. This HAP on only port 1 is allowed to go to the internet.
Right. Yeah, you're right. You cannot route it back to the 5 gig.
Correct.
Okay, that answered it. You cannot do that.
Yeah, it prevents it. So I can tunnel through the internet. That's the whole magic of Arden, is it allowed me to tunnel through that connection to another location, but I can't. It never routes the eBay traffic
over the air on 5 gig.
Yes.
Yeah, that it cannot do. Right.
Yes.
Right. Yeah. Because I wouldn't think, and that is going to open up legality. The other guy's non-licensed. Okay.
Exactly.
Yeah. So you cannot. Let's say I'm sitting by my laptop at home. The internet's down. Suppose something like this happens, and I want to go to some website, a WWSO website. That you cannot do.
Correct. You can go to
you go to someone else like
you.
You
Go to my
like
house.
Right.
You can reach my Wikipedia server, but you can't
Right.
reach www.
That makes perfect sense. Makes perfect sense. Perfect sense. Thank you.
All right, thank you, Rachel. Let's give Rachel a big hand.